Now we're going to take a look at number 9 to number 15 in the multiple choice questions. Number 9 presents itself like it's something that you've seen before in algebra class. It's a system of two linear equations. These equations are both written in standard form, so that means that they're written in ax plus by equals c form. And normally you would solve these questions by using either substitution or elimination, but in this case, because of what they're asking for, what's the value of 6x plus 6y, we don't necessarily need to solve for what x is equal to and what y is equal to. Instead, there's a shortcut. So all that requires is just to make the observation that if you add x and 5x, you get 6x. And if you add 4y and 2y, you get 6y. So in essence, we just have to add these two equations together. And when we add the 9 and the 27 on the right-hand side, we find out that the value is equal to 36. Okay, so again, even though this has a shortcut, we do need to remember on the SAT that you can solve linear systems, right? Systems of two linear equations, linear systems, by using either substitution, elimination. Uh, you could, of course, find the solution if you were able to graph them, or if you had the graph, you would just look um, for the actually I've written down this wrong. It's not the x-intercept. You're looking for the intersection point. Or, as we did in this case here, because of what they're asking for, we found a shortcut by just simply adding the two equations together. Okay, so let's look at number 10 next. In number 10, this is a situation where looking at the answer choices and seeing what the answer choices are is very, very helpful. When we look at the answer choices here, we could see that they're all linear equations, right? They're all in the form of y equals mx plus b. Now, of course, they've done some substitution, right? So instead of y, they're using s. Instead of x, they're using h. So this is s equals mh plus b, essentially. Um, so one thing that we need to remember when we have something that's a linear model, right? We're using a line equation to represent something in the real world, a real world scenario, like here Nina and how much money she has saved. That the y-intercept value that represents the starting value. Therefore, if the slope is positive, that represents a positive rate of change, right? It's going to increase from there. So that's why we, are going to use what we know about starting values and the slope to figure out which has the correct information taken from the problem itself. Well, one of the things that we find out is that she starts off with $842 in savings, and then she's increasing her savings from there, right? She's working to make more money. Well, we don't need to go any further because there's only one answer choice that has a starting value, or in other words, a y-intercept that's equal to $842. So the answer has to be C. We don't even need to consider anything else then. Okay. Now, if you want to find out more specifically, like why is 19 the correct slope value, that's just because we know she's earning $342 after she works 18 hours, right? 3 times 6-hour shifts is 18 hours total. And that can convert into a slope value, right, of 19 over 1. Now, of course, we don't have to write a fraction 19 over 1. We can just write it as 19, and that's why the slope is just being written as 19. So that $19 per hour, that represents the unit increase, or the unit rate, rather, of how she's earning her money. Okay, so let's go ahead and look at number 11 next. In number 11, we are being given the slope, right? So obviously that's an m value. We know that that coordinate is on the line. So that means that we're being given an x value of 8 and a y value of -2. One thing that I'm noticing is that they're not asking for the y-intercept. Normally, you're probably more accustomed to being asked for the y-intercept. We're being asked for the x-intercept. So how does that affect our calculation? Well, we can't just straight up solve for b, right? If it was solving for the y-intercept, we could use just y equals mx plus b and solve for the missing b value after we're substituting in the x, the y, and the slope that we're being given. So that takes this possibility out. Now, there are three forms of a line equation that you learned. The first two definitely, right? So everyone's learned about standard form, ax plus by equals c. Everyone's definitely learned about y equals mx plus b, the slope-intercept form. The third form, you probably learned it, all right? But you don't really use it much, so then it's easily forgotten. This is known as point slope form. It's nice to know point slope form, and this is a perfect example of a question where why that works so well. Because in point slope form, we can plug in a coordinate x1 and y1 along with the m, and then plug in what? We can plug in y equals 0, y equals 0, because at any x-intercept, the y is 0. Look at the graph up here, all right? Any point that crosses the x-axis has a y value of 0. So if we want to find the x-intercept, just set the y equal to 0. So if we plug in y equals 0 over here, along with the coordinate that we're given, x is 8, y is -2, the slope of the line is -3/7, we can then solve for the missing x value. That'll be our x-intercept value. So from there, we just need to do a little bit of algebra, all right? I decided to clear the fractions, right? Just get rid of the fractions right away. Since there's only one fraction with a 7, I decided to multiply by 7 on both sides. Every single term gets multiplied by 7. That gives me this, and then from there, we just wrap it up, and we find out that x is equal to 10 over 3. So I would also just mention really quickly, this happens to be a question where if you look at the graph, you'd probably also notice that a couple of the answer choices don't make any sense at all, right? Like if we look at the graph up above, we can see clearly that the x-intercept is on the positive side. So how could it be A? How could it be B? We could eliminate those two answer choices if we were trying to guess from the remaining results. Okay, so let's take a look at number 12. So in number 12, this is just a quadratic equation, all right? I would say that one of the most important things when you have bigger numbers show up in a quadratic equation is see if there's any way to simplify it, all right? There is a way to simplify this because 7 minus 42 and positive 63, they're all, divisible by 7. So we can just simplify by just dividing by 7 on for this particular equation, right? Luckily on the right-hand side, 0 divided by 7, it's still 0, right? So the end result is basically that maybe scary looking quadratic with the big numbers initially becomes just x squared minus 6x plus 9 equals 0 then. And hopefully you can factor that comfortably. It's x minus 3 times x minus 3. And therefore, that tells us that there's only one solution, right? Because both factors end up being the same, and that's x equals positive 3 then. Now, here's a little bit of a bonus thing here. So just be aware, they like to put things that are scary, right, on the SAT math section. So sometimes you'll get things that aren't quadratic, right? Notice here, the highest degree is x to the 4th, not x squared, but we can still end up kind of like factoring it using what we know about quadratics. So how do we get x to the 4th? It's just simply x squared times x squared. And then the other terms kind of like work out the same. Okay. And I also just want to make a notice here. If you did have to factor something that looks like this, x squared minus 3, you might say, oh, I can't factor that because it's not a perfect square. You can factor x squared minus 4. You can factor x squared minus 9. You've probably done it multiple times in algebra class. But even this is technically factorable. All right. And again, these are going to show up on multiple choice questions. So you'll have answer choices to kind of like, help you navigate through it. But if you multiply root 3 times root 3, that's equal to 3. So if you actually work this out, FOIL it out, you'll find out that, yeah, it does indeed give you the original x squared minus 3. Okay, and sometimes they'll even do something like this, all right, which again looks scary, but if we kind of follow along with the factoring, what we've learned with quadratics, this is actually factorable as well. So these bonus little ideas here are examples of like harder factoring problems that show up on occasion on the SAT. And I'm just showing you that if you're a little bit, perceptive about just kind of treating it like a quadratic, you can get things done. And again, it's going to be on the multiple choice section, so don't feel like you've got to just like come up with it completely on your own. You can usually pick up some clues in the answer choices that are available to you. Okay, so let's take a look at number 13 next. Okay, so we've been speaking about quadratic equations. This is a quadratic function. This is a quadratic function that is being written in vertex form. Okay, because vertex form are things that look like this. So what can we find out about this? Well, the a is something that's positive. It's positive 3, so this means that the parabola has to open up. All right, remember, when the a is positive, it's like a smiley face. A positive person smiles. If the a is negative, a negative person is sad a lot, so it's going to open down. So um, the vertex, we can also get that. The vertex is going to be what? Well, based on what we know about vertex form, which is its h comma k, the h will pull out, right, from here, and it'll be positive 3. If you have trouble remembering that, you can kind of just think it's always the opposite sign for the x coordinate in vertex form. However, the y we just kind of take out as is, so that's going to be positive 35. Well, think about that. If the parabola opens up and it's got a vertex which is somewhere above the x-axis, is that function ever going to be less than 0? Uh, the function value is the y value, all right? So x is inside the parenthesis. Function notation, when we talk about the function value or the use of function notation, we're talking about the y, so the verticalness. Well, it's never going to intercept the x-axis. It's never going to dip below into the negative territory. So therefore, the answer here is there'll be no x values that'll ever make this parabola have any negative function values. Okay, and then just down here, I made a note here, just reminding you, you could also just use the discriminant if you wanted to. All right, so if you FOILed everything out, put it into standard form, and then did b squared minus 4ac, that would be another way to kind of like find out like what's going on with the x-intercepts, and you'd find out, oh, there are no real solutions for this particular question. There are no x-intercepts, and therefore that would also mean that it's not dipping down below. Number 14, the graph of that thing which is in factored form, right? We have two factors in this quadratic, this parabola. So this is another form of a quadratic function. When it's in factored form, another name for that is the x-intercept form. So from here, we could set each factor equal to 0 in order to get the x-intercepts. So when we set 2x minus 6 equal to 0 and solve for x, we get x equals positive 3. If we set the factor x minus 7 equal to 0 and solve for x, we get x is equal to positive 7. So how can we get the vertex for this given the x-intercepts? All we have to do is just simply average the two x-intercepts. Okay, so if we add 3 and 7 and divide by 2, we get the x-coordinate for the vertex. If we plug in that value of x equals 5, we get the y value, it's negative 8, so that means that the answer is A. You could also, if you don't remember that fact about finding the vertex from the two x-intercepts, you could also just FOIL it out. And when you FOIL it out, then you can rely on the whole x equals negative b over 2a, right? You might remember that from algebra class. And then when you plug in the b values and the a values, if you solve for that, you get x equals 5. And of course, y equals negative 8. So our answer is confirmed, right, from the other method. And then you could also use a little bit of like reasoning skills here. If you do have those two x-intercepts at x equals 3 and 7, and you know that this parabola opens up, right, because the a would be positive. There's a positive sign in front of the x squared term. That means that the parabola opens up. So that means that the vertex would have to be in the fourth quadrant, right? It has to be basically below the um, x-axis. Sorry, I was trying to think about like which axis it was. So it has to be below the x-axis. So the only answer that gives us something in quadrant 4 below the x-axis and on the for a positive x value would be A. Okay, and then we got one last question over here in the multiple choice. So we have a system of two equations. So we mentioned before, if you have a system of two linear equations, you could use substitution, elimination. You could graph it, of course, or if there's a shortcut, it kind of just depends on like what you're being asked for. In this case here, the only route that is going to make sense probably is substitution. All right. The second equation is a lot simpler, but it can be rewritten as x equals 8y plus 1. Now, they are asking for, the quotient b over a. I could work with just the x and the y, right? But if you really want to work with a and b, you could substitute in x equals a and y equals b because, again, a coordinate is giving us an x and a y value. So actually, I did go ahead and do that over here. So if you replace the x and the y with a and b, respectively, there I'm showing you that this is the substitution I'm using, a equals 8b plus 1. If you plug it in, it looks ugly, but it cleans up very quickly. And then you find out that b is equal to 1. If you plug that back into a equals 8b plus 1, you know that a equals 9. So the answer is 1/9. Now, you might also notice this, all right? There's a little bit of a shortcut. If you noticed that when a is equal to 8b plus 1, you could plug in a b value of 1 and then establish that the a would just have to be 9, right? And you could do that for any b value, like b equals 2. If b is equal to 2, then a is equal to 7, equal to 18. Um, so, or sorry, 17. Um, let's see here. Yeah, so anyway, sorry, I got a little bit distracted. So anyway, you could have gotten the answer really quickly. Oh, actually, there has to be because of the system. It's a little bit of like a lucky coincidence, actually. It's not a perfect plug-in scenario. But anyway, if you do solve it by plugging in, you can kind of luck out and get the right answer. But this is a good case of a case where you could kind of shortcut this thing a little bit. Okay, so that's it for the multiple choice.